Hello my friend, welcome to my channel. So today we are going to graph another rational function y equals x square plus 1 over x minus 2. This rational function is a little bit different than the previous rational functions we discussed. So let's look at this one, okay? So first let's look at the domain of this function. So to find the domain of this function in a rational function, you have to look at the denominator. So your denominator equals x minus 2. So you have to find x value where your denominator equals 0. So solve for x, then you get x equals 2. So at x equals 2, your denominator equals 0. So therefore you have to remove this point x equals 2 from your domain. So then your domain will be negative infinity to 2 open parenthesis union open parenthesis 2 times infinity, right? So you removed 2 from your domain. So this is your domain for this rational function, okay? So let's look at the x-intercept, if any. To find the x-intercept, y value equals 0, right? Y value equals 0 means x square plus 1 equals 0. So y equals 0 if this one equals 0. So as you can see, if you simplify this one, it is x square equals negative 1. So that means x equals negative 1 square root, right? So square root of a negative number. So this is like a complex number. So therefore we in this case we don't have x-intercept. See, this is a complex number, right? We don't know how to find the negative 1 square root. It's not a real number, right? So this is a complex number. So in this case no x-intercept, okay? And let's find out if there is an y-intercept here, okay? At y-intercept, you know the x value equals 0. So let's find y when x equals 0, right? So here you have negative 1 over 2. Okay, so y-intercept is 0 comma negative half. Okay, now let's find the horizontal asymptote. To find the horizontal asymptote, you have to look at the numerator and the denominator. As you can see, the degree of the numerator is higher than the degree of the denominator. The degree of the denominator is 1. So here 2. So in this case, your horizontal asymptote will be the quotient of the division of this x square plus 1 divided by the numerator divided by the denominator x minus 2. So the quotient will be your horizontal asymptote. So you know I'm going to use the long division here. So here you have x square plus 1. So we don't have the linear term. So I'm going to write linear term like 0 times x plus 1, right? So here we have x square plus 1. So I'm going to write this one because I'm going to do the long division. So here we have x minus 2. So I'm going to look at x square. To get x square from this one, I have to multiply by x, right? So I'm going to write x over here above the linear term. Then multiply x times x minus 2 gives you x square minus 2x, right? This 2. Then I have to subtract these two, right? X square minus x square equals 0. 0x. Here negative, which is positive, right? See, positive 0x, positive 2x. So you have here positive 2x, right? Then I'm going to take this term like this and then look at 2x plus 1. How do I get 2x from this one? You have to multiply by plus 2, right? 2 times x is 2x. 2 times negative 2 is negative 4. Then I have to subtract these two. Positive 2x minus 2x is 0. Here you have positive 1. Here negative, positive. Positive 4, positive 1. equals positive 5. Okay, so we have to look at the quotient. This is your quotient, right? So quotient will be your horizontal asymptote in this case. That means y equals x plus 2 is your horizontal asymptote. Okay, it's a linear function. Then let's look at the vertical asymptote. You have to look at the denominator to find the vertical asymptote. So here at x equals 2, denominator equals 0. So your vertical asymptote will be x equals 2. Right? Because at x equals 2, your numerator is what? It's 5. It's not 0, but denominator at x equals to 0. So that's how you find the vertical asymptote here. Okay. So now we have all this information. Let's graph this one. First, graph the horizontal and vertical asymptote. I'm going to draw vertical asymptote x equals 2. Right? X equals 2 is over here. Right? This is my x equals 2 vertical asymptote. Right? And then horizontal asymptote. This is y equals x plus 2. So thus here slope of this linear function is 1, right? And this is my y-intercept is 2. So your graph goes to this point, right? And as you can see, slope is 1. And what is the x-intercept here? At x equals negative 2, y equals 0, right? Negative 2, y equals 0. So then if you connect these 2 points, then that's your horizontal asymptote. So in this case, it is not horizontal, but it is like a slant, okay? It's like a slant, but it's not horizontal, but it is a slant asymptote, okay? And so this one is your y equals x plus 2 slant asymptote, right? There's a it's not horizontal now. So now you have 2 asymptotes. Now let's graph this one. I found that my y-intercept is 0, negative 2. 0, negative, not 2, negative half, okay? 0, negative half is over here, right? And then I need 2 points to identify, because there's a asymptote here, another asymptote here. So let's look at the shape of this graph. Let's find at x equals 1, what's the value of your function? Y equals x equals 1. 1 square plus 1 over 1 minus 2, right? Function is x square plus 1. So y equals x square plus 1 over x minus 2. At x equals 1, 1 square plus 1, this is 2 over negative 1, which is negative 2. So at x equals 1, y equals negative 2. At x equals 1, y equals negative 2. It's over here, right? Okay, so you can see the shape like this, because this is a vertical asymptote. It goes to negative infinity this side, right? And what about this side? As you can see, there's a asymptote, another slant over here. Then you will see that shape of this. So it goes like this, okay? So goes to negative infinity here. And this side, as you can see, there's another slant. If your graph will go like this, right? Another asymptote. Just go like this, right? And then okay, there's an intersection of your asymptotes, right? Here you have 2, 4. There's a intersection here. And then if you look at this one, here it goes to negative infinity at this asymptote. Then your graph should goes to positive infinity from right? So it comes from here And what about this one? So the shape of this one will be, because of this asymptote, it goes back like this, okay? Because of that asymptote, okay? So here in this side, from left, it goes to negative infinity, and at this asymptote, it goes to positive infinity from right. It comes like this. Because of this asymptote, it goes like this, okay? So this is the graph of x squared plus 1 over x minus 2. Okay. As you can see, there is no x-intercept here, right? So we couldn't find the solution of the x-intercept function here, right? The equation we couldn't solve it because it is complex numbers. So this is the graph of this rational function. So I hope you understand this one. If you have any questions, please comment. Thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.